This is section 6.2, absolute value. An absolute value is simply a distance away from 0. Thus, my absolute value always must be positive. As we all know, distance must be positive. So if I'm looking to solve number 1, I need to first remove the absolute value signs to get x alone. And when I do that, I'm going to get x minus 3 could have equaled a positive 8.7, and the fact that x minus 3 could have equaled a negative 8.7. Please notice that while in the absolute value signs, my solution is always and every time positive. To remove those absolute value signs to get x alone, that gives me both a positive solution and a negative one. So here in number 1, I'm going to end up with 2 solutions. When I add 3 to both sides, first I will get 11.7. And here when I add 3 to both sides, I will get a negative 5.7. Now we also define squares as the fact that if we take the square root of something squared, it has to equal the absolute value of x. So for x squared equal to 20, I am going to square root both sides. And notice how many solutions I get here. First, I'm going to get the positive square root of 20. And second, I'm going to get the negative square root of 20. Notice that when it's actually squared, that value has to be positive. And so let's go ahead and simplify these. And I get x equals 2 square roots of 5. And x equals a negative 2 square roots of 5 when I bring out the square root of 4. Oh, I'm missing my absolute value here. So excuse me, in number 3. Let's shimmy those in here. And now number 3, I'm going to solve for y by first getting it alone. And so to get it alone, I need to take out my absolute value signs. And when I do, I get 2 solutions. What's inside the absolute value sign could have been positive, or it could have been negative. Now I'm going to solve both of those equations, subtract 34 on both sides, and on the left-hand side I get a negative 24. When I divide a negative 24, a negative 22 by negative 2, I get 11. And over here I'm taking a negative 12 and I'm subtracting 34, and I end up with a negative 46. And when I divide both sides by negative 46, I end up with a positive 23. Now tomorrow we're going to practice plugging our solutions back into our equations to make sure we get right solutions. But for now, I just want you to notice the process. For number 4, to get x alone, first I would need to divide both sides by 3. And I get x squared equals 6. When I square root, hopefully you notice, I'm going to get 2 solutions. A positive square root of 6 and a negative square root of 6. That got a little messy, sorry. X squared equals 6. I square root both sides, and x is going to equal a positive and a negative square root of 6. All right, if we have a square and a triangle that have the same area, triangle has a base of 7 and an altitude of 6, and we want to find the length of the side of a square that equals that area. First, let's find the area of this triangle. My area is always 1/2 base times altitude or height, and hopefully you'll agree with me, I get 21 centimeters squared. If that is the area of my triangle, hopefully you agree the length of the square is going to be s squared should equal that same area. Now we're going to square root both sides, and end up with two solutions, a positive and a negative. In a real world situation though, can I actually have a negative length? Absolutely not. So I'm just going to keep the positive square root of 21 centimeters. That is the length of the side of my square. For tomorrow, I would like you to try this, this number 7 on your own. Please solve 4x by writing two equations and getting both a negative and the positive. And then I'd also like you to try one that we haven't really done yet. I'd like you to try both 7 and 8, and I will see you tomorrow.